and we'll go like this. All right, so just a recap from all of the graded stuff that I've just done. The number one mistake, and it's probably 1 to 2 people per class, but it is critical that we know that you know what's going on. So a lot of people had like function definitions inside of function definitions. That can never happen. It will not. Well, some people wrote programs that still worked coincidentally. It's not supposed to work, but regardless, function definitions never go inside function definition. When I load up, when I load up someone's program and I see like definitions inside of definition, I know immediately that they need some help or need to go back. It's fine. This is day 5 of programming, day 4 programming, whatever. But it's critical moving forward. Question.
What if it's something that is like that our functions?
Well, the definitions never go inside of other definitions. They are standalone tools in your toolbox that you make, put at the bottom of your code, and completely forget about.
But I can put my function definition inside of, I guess, like another function.
No, you could put function calls inside of. That's necessary. That's abstraction. That is using lower level stuff for higher level stuff. No. Calls have to go inside. Definitions cannot go inside. Like the definitions are like the bracket sort of, I consider sort of protecting this code, or blocking it from running. Regardless, that's a big problem moving forward, but that's fine. We'll figure it out. All right, so we are going to go, I have everything going. We are going to do, like I said, lesson 8 from the get-go, and put that there. And all right, so lesson 8, fantastic. Every time we move forward, we're getting more and more tools, more and more abilities. And yes, it's getting a little more complex, but that's more ability. Give me. We are now going to write our own functions that receive parameters. That is awesome. That is the way of functions. That is how you use functions, is you make them customizable. You plan ahead to make something that will work in many circumstances. And we're going to start out with the video that explains it. If you're watching the replay, this is the one we're watching, but I don't think it's going to show up in the replay, because we're going to watch it on the big screen. And let's go like that. So this is the one we're going to watch and enjoy. Let's go like this.
The more generally useful. We've already seen that some functions are defined with parameters to make them more generally useful. For example, the original version of move forward moved the turtle exactly 25 pixels. This doesn't give you a lot of options on how to design your drawings. A much more useful version of move forward is one that accepts a parameter that allows you to specify exactly how far forward the turtle should move. Up to this point, the functions we've written ourselves don't have any parameters, but the ability to write your own functions with parameters is both useful and powerful. So let's see how to do it. Here's an example. Look at this function that draws a square with sides that are 100 pixels long. If we wanted to make a function to draw a square with sides 50 pixels long, we'd have to make a new function that's almost identical to the first one. with the only difference being how far the turtle is moving each time. If we wanted even more options for the size of the square, every time we would need to declare a new function. Yeah, that's not very good, but luckily there's a better way. The solution to the problem is the ability to create a function that accepts a parameter. A parameter is a named value that is provided as an input to the function. We saw that our version of draw square has a lot of code that was repeated. The turtle was executing the same basic behavior, just moving by different amounts. It turns out that we can express this generalized behavior in our code as well. Here's a new version of draw square. Here, we've made the size of the square a parameter of the function. Notice that the function heading declares that it needs an input. We've given a name to that input, and that name is size. Everywhere in the code where we need to use that value, we just enter the word size instead of a number. Writing a function with a parameter is very similar to writing a function without one. Just drag the function block that shows a parameter and drop it into the workspace. We add the name of our parameter inside the parentheses in the function call, like this. Just as giving a meaningful and descriptive name to your function is important, so is deciding what to name a parameter. The name of a parameter should give some insight into what the value will be used for. In this case, we've chosen the name size to indicate that you can set the size of the square when calling the function. As a programmer, what you call your parameter is your decision to make. We can write the body of a function like this. The parameter, size, acts like a placeholder for that value. Wherever we want to use that value, we just refer to it as size instead of a number. Let's look at what happens when the function is called. Now, when a user calls draw square, they call it with a value like this. We say the value of 63 gets passed to the parameter of the function. The parameter acts like a container with a name on it. Whatever value is passed into the function is stored in that container. Inside the body of the function, you'll want to use the value stored in the parameter. To do so, you must refer to the value by its name. As the program is running, whenever the word size, in this case, is encountered, it's replaced by the value stored in that parameter. Adding a parameter to our draw square allows us to generalize its functionality. In other words, our function is useful in an entire range of situations, as opposed to just being useful in one particular instance. The result is a function that gives you much more flexibility and control without the need to create duplicated code. Once you've added a single parameter to your function, you might realize that there are multiple aspects of its functionality you'd like to generalize. For our square example, you might want to change the width or say the color of the line. To do this, you can simply add more parameters and separate them by commas. You can then use any of these parameter names in the body of your function. When calling your function, you'll need to include multiple values, one for each of the parameters and each one separated by commas. Parameters are another example of how abstraction can be used to solve problems. When confronted with a group of related problems, we first look to identify patterns across all of them. In doing so, you might realize that using parameters will let you define a single function with general behavior that can solve any instance of the problem with one piece of code. This is a powerful skill that removes the need for creating duplicated code and leads to programs that are easier to read, write, and maintain.
Go ahead and jump into lesson 8, I suppose, bubble 3. And we can go to full screen here and share in the back. There we go. All right, so bubble 3 for lesson 8. We are going to make some functions that receive and use parameters. If it loads up, we'll go full screen a second. All right. There we go. Let's go like that. And we're loading. Like I totally just did this. Let's see. Oh, is this how you get here? This is what your code looks like when you get here? Oh, that makes way more sense. All right, so what do we have for this one? Well, when in doubt, we'll run it that straight away and see what happens. So clearly there's some stuff messed up. Okay, defining a function use a parameter. Clearly something's wrong. I don't think they should have jumped in with this, or I don't know. That's fine. Okay, so we have a function definition that is expecting a single parameter called size. This is actually one of the first times that explain that there are so many things in programming in this language specifically that it doesn't matter what you call them from the computer's perspective. Okay, this parameter could be called anything, but wherever you want to use it, it needs to be called the same thing. Okay, and a DSF is not going to work. Okay, there's no reason to call it something other than size because that makes sense, and it will help you figure it out later what it's supposed to be. But regardless, when you call the function, you're going to send it a number. Because you know this function is receiving or expecting a parameter, a value, when you call it, you have to give it one. And depending on what you put in there, it will be applied to the parameter, and anywhere inside the function where the function where it uses the named parameter, whatever value you send to it will be used in that place. Okay. In this case, we have an issue where it's supposed to be, it clearly looks like it's supposed to be close to this, but not exactly. We have some basic pen up, move to, whatever. The functions are sending a number. Okay. When we get into different data types like numbers, strings, Booleans, lists, whatever, you need to know what it's expecting. And when you have multiple parameters, you'd have to send multiple values with whatever it's supposed to have. But either way, it's expecting a value, and the way it's written is supposed to be a number. And everywhere it's going to replace the move forward length, the length of the square, and then a standard 90-degree turn, move forward, 90-degree turn. Then it has move forward a hard-coded amount. Okay, having parameters makes it customizable. The more hard coding, the more specific numbers you put in, the less you're using that parameter. And in this case, that's the problem. No matter which function we call, or which parameter we send when we call it, it's going to use 33 as the length of the third side, which is not what we want. We want a square, so we want all of the move forwards to be whatever number we send it. Also, you probably could have figured out the pattern that it was size 90, size 90, 33, 90, size 90. So there's that. But you have to think about what you're actually sending it and where you're going to use it. All right, bubble 4. I should just flush this out when I get started. Okay, so this apparently is what you get when you get here. What do we have? Well, okay, when in doubt, hit run. Nothing happens. Okay, nothing happens because the program starts with pen up, does all its move forwards, its move arounds, and nothing is inside the function, and the pen is also down. So that's another reason why it's not drawing. So we want to make the function or define the function called draw triangle. They've given us a hint that it's supposed to receive a parameter that we will apply to the length of each side of the triangle. It's already being called, sending it different sizes as that. So what do we need to do in order to draw this? I mean, I rarely do pen down inside a function definition, but it's fine. And so what's the first step for drawing a triangle? It's move forward. How far do we want to move forward? How many pixels? We want to move forward side length number of pixels. Whichever number we send will be stored inside of this parameter for the duration of this function when it's called one time. Then the next time when it's called, it will send this number, be stored in this parameter, and every time it's called, use that. It will be that for the duration of the function call. Okay, so recall from before, triangles require 120-degree right turn, and we need 3 of them. Well, 3 sides, each side being side length, whichever number we send, and need to do pen up at the end. Which is why I usually do pen up, move to pen down. But it doesn't, as long as it works, it's fine as far as where you're putting pen up and pen down. But that's it for this one. The length of each side is side length. So we can make any size triangle for the duration of the program. Turn left. Oh, do they want turn left? I should have paid attention to that. Turn left, 120. Let's go like this, and like this, and oh wait, pen up at the end. Is that what it wants? Weird. But yeah, there you go. What's up?
Oh, wait. Can we put
It's got to be. It has to be turn lefts
yeah, I know, but can you scroll
to
down?
bubble 4. Are you still on 4?
No, yeah.
Yeah. I mean, the one I just finished. Did it not work?
Oh wait, no,
Did
that's
you-
why. That's because I had to put the pen up. Yeah, bottom.
Yeah. There you go. Okie dokie, bubble 5. Which I promise will load eventually. And okay, so here we have a function set up for us that is expecting 2 parameters. First one is going to be used to draw the length of each side of the square. And the second one is going to be applied to pen width. Now, it's important to note which order they're expecting, or which order they are expected in, I should say, because that's what they're going to get applied to. Okay, and we're using border width to be applied to pen width, and size, like I said, will be the length there. All we need to do for this one is make 2 calls to it. And so we're going to do a function call, and it doesn't matter really whether you pull out the function with a parameter or not, because it has this little arrow at the end that will allow you to increase the number of parameters with the order mattering significantly. And mattering in that's how it has to work. Okay, so for this one, we need to make we need to call the function draw square twice, and we need to, does it say what the sizes are? No. Okay, so let's say this one is 100 pixels on a side and the pen width is 8. Just guessing. And yeah, there you go. That's good. And then we need I'm not sure this is even worth that. Okay. We then have move to the second one, and we're going to call draw square again with different values. And the other one in the other location is much smaller. I'm guessing it's 50 on a side, and its pen width is bigger, maybe 15. And we need to name it, which whenever you get any sort of error, okay, yellow triangle means possibly an error. You can mouse over and it will tell you what the problem is. In this case, my function hasn't been declared yet. Yeah, because I haven't. There's no function called my function. And so we have draw square. We have calling 2 parameters, or I should say sending 2 parameters. And those parameters are going to be received like that. Let's see. And there we go. That is that one. Okay, we'll go on to bubble 6. All right, so we need to write a function that deals with, what are we supposed to have this do? Pen width and length? Are those the only two? Yeah, size and width, or pen width. So we have our function. Try. Okay, so I'm just gonna throw some white blocks in there. And let's go like this. Probably not the best way. Okay, so we have function calls. We need to define our function. We've already named it, or they've named it for us, draw a triangle. We need to have it receive 2 parameters. Okay, they are telling us what they want those parameters to be called. Like I said, they can be called anything, but there's no reason to not have something that makes sense. But I am going to make a point moving forward that there are like things that could be confusing, and as far as words being reused or not reused, well, that's more of an issue when we get to variables. Okay, so draw triangle. They have the pattern of doing pen down before you draw and pen up at the end, which works just as well as anything, but it's not the way I usually do things. And so we need a move forward to draw one of the triangles. How far are we going to move forward? We're going to move forward size. Because when we call it, it will be a number. It will get passed to this first number, or this first parameter, and everywhere we use it, whatever number we send will be that. Then we need a turn right. Is it a turn left? It is probably a turn left. And turn left 120. Let's just see if that does a thing. Okay, that's not good. Because, well, I have 2 functions going on. So let's finish it and see what happens. So that is the triangle. Obviously, we need a pen width thing. Let's just see if everything's in the right location. Okay, so we have 2 triangles. You don't technically have to use every parameter. It is receiving this number and being held in this container, waiting for you to use it somewhere in this function. But it's not going to break if it's not there. It's not going to break if you don't use width. Or if, hold on, will this break it? No, if you send it extra parameters, it's just going to ignore them, which is There's no point to that, but it's not a game breaker. And what do we need? Oh, pen width. Before we start drawing, we need to make pen width, and it is going to use the parameter width, which is whatever number comes second inside the parentheses. And this should do the trick. There we go. Give me a second. I don't want to do, this is a middle.
Show up. That's
Why did what?
my pen didn't show up.
Did you make pen width and have it received there? Okay, bubble 7 is a check for understanding that we can go over together. Which of the following is not part of defining a function? Giving the function a name. Absolutely, we need to name it. Identifying the parameters of the function. Sure. If it has parameters, but yes, that's part of defining a function. Giving the parameters value. No. Defining a function is creating the tool that can receive any value for its purposes, but the calling of the function sends the number. That's where you give the values. The definition receives them and uses them. And adding code to the body of the function. Yes, that's just coding the function. Okay, so now we're going to see comments. Comments used in their natural habitat. So I've used comments before just as a place to put something or a way of organizing it, which is what the comment is annotation, a little note to yourself. And yes, our programs are maximum simple, and that, whatever, like I said, day 4. But when things get more complicated or more detailed, you would want comments in your code to help, or really for your future self, which, do your future self a favor. And so 2 ways to do it in App Lab, just dragging out the comment code or the comment block, or you could switch to text mode and do // which is the for real JavaScript way of writing a comment. Yeah, other people and self, that's everybody. But you and others makes everyone. Comment their code. Thank you, human reader. We will usually see comments above function definitions. As we get more complicated functions or write your own more complicated functions, you'll put a comment above the definition really to remember how the different parameters are used. So if it's expecting 3 or 4 parameters and they're completely different data types, like the first one is a word, like for a named color, and the next one is the size of something, and the next one is an entire list that it's going to do something to that list, having a comment that explains what those things are or what the function is expecting is super useful, especially if it's something you wrote months ago. And so comment. Yeah, planning out like I've done before. Okay, bubble 9. Is this is what you see, right? You get some code when you get here. Do you? Okay, that's what I didn't have to refresh it. I thought I did. All right, so this under the sea scene, which I have a hard time not saying, like Little Mermaid, under the sea. We're going to work on this in several different stages and keep adding to it. And I think, is it all? Okay, so all we have to do is add a comment. Okay, you can see the other examples that have draw all the seagrass, and then what that does. Draw all the fish. Okay, the only one that is missing a comment is the draw starfish, which the comment block is inside of the functions toolbox because it is most commonly used with functions, and drag it out there and draw the starfish, which that's sort of useless in that the name of the function is meaningful and descriptive. But like I said, as there's more information to remember, there's more use for comments. And I think that's it for this one. Yeah, I think that's it. Are you finished? Yeah, all right. So there are some bubbles that will let you just hit it because it doesn't have a criteria to check for. But obviously some of them, it does have a criteria to check for.
Or it's like a random, kind of like,
That means it's checking for a specific criteria, like it's looking for a function called something, or named something, and it's called 3 times. If you named it something else, your program will still work, but that's not what it's checking for, which is a limitation of writing a curriculum like this, but that's fine. Okay, read through the program, add a function call in the early lines of the program, so that 2 starfish, 2 fish, and 2 pieces of seagrass appear somewhere in the scene. You need to call move 2 before drawing the second one, unless you want it drawn on top. And yeah, you don't need to provide values for the parameters at this stage. Okay, so each of these are function calls, and they all relate to the function definitions towards the bottom. And that will be our format for our program code. The definitions get figured out and put at the bottom of the code, and we don't need to look at them anymore. And then all the function calls, the moves, the sort of basic interaction will be near the top, so we can solve it, completely ignoring what needs to happen in order to draw a fish. Okay, so let's see what we have when we get here. Okay, it works at least. We need 2 of everything. So we're going to move 2 and draw fish again, or draw starfish. Let's make it a little bit to the right, which is above 160. How about 220 something? I'm not terribly concerned with what you use for these values, as long as it works and whatnot. And a Y value, maybe a little bit less high, like 375. And call draw starfish, we should have 2. That's way too close. With no, let's try 275. Okay, that's good. And seagrass. So draw seagrass is interesting because in order for it to work, it needs to start all the way at the bottom of the screen, and it needs to point north in order for it to work. You can see they're using turn 2 again because we don't know what angle the turtle's pointing at the end of whatever other thing it's drawing. So in order to make sure that it works, we plan it out for it to start pointing due north, and we need a different X value though. Okay, the first one's 50 in, maybe, I don't know, 120 from the left, because the X value is the distance from the left. And there we go. And then we need another fish, which we have it at 100, 100. And this is just as valid a way of figuring out location is if your app isn't running, meaning you either just loaded it or you hit reset. If you can read the word run, it's not running. Mouse over the screen and you can see the XY coordinates of the place your mouse is. And if I want the other fish over here, I'm going to do move to 200, 125 for the second fish. 200, 125. And there we go. that the last one? Do we have one after drawfish? Nope, that's it. Move to, your code will be waiting for you. Okay, so this is a carried over situation. So what that means is when you get to the next one, you can't really do start over because it'll start over everything. But you can still do version histories if you get trapped. Okay, so we have a draw starfish function that is not receiving a parameter. It's drawing a hard-coded dimension of, let's go down here and look at the draw starfish function. It's hard-coded. It's using the exact distance of 60 for each of its sides. And we want the ability to make different sized starfish. Starfish is the plural. We want to add a parameter that will be used as the move forward length. So let's add a parameter, and let's just, I mean, there's nothing wrong with the word size. It doesn't have to be size, but it could be anything. And then instead of any place we had move forward 60, we're going to move forward size. Now, when we call draw starfish, we need to send it some numbers. What will happen if I don't think anything will happen. Oh, I think when you call move forward with no number, it does the 25 again, but that's a app lab thing. Don't worry about that. Okay, so when we call draw starfish, we need to send it a number that will be used as the move forward length. The default was 60, so we need to give it a number that's sort of like in a useful range. Something like 150 is not going to work. I'll put this other one back to the regular size because of the size of the pen width and whatnot. So let's maybe one a little bit smaller than our standard, which was 60 was our standard, and maybe one a little bit bigger just for demonstration purposes. And even 70 is a little too big for that center thing. We could increase the pen width, but we don't need to. Let's just leave that one at 60 and maybe 60 and 30. Okay. You could, of course, write your function to receive a different pen width or have the pen width be a certain ratio based on the length. So if it's a small size, you could set it up so that it would use like size times 0.2, and then the pen width would always be 20% of the length at whatever it ended up being. That would work. But for now, we are just giving it values that work. Okay, so our draw starfish function just receives one parameter to be used as the side length, the size. And let's go on to bubble 12. Okay, same thing for seagrass. We want to add a parameter that will adjust the radius of the arc, which will change the size. Okay, these seagrass have I don't know, 4 arcs, 5 arcs, 6 arcs, something like that. And the size of the arc affects how tall it is because they stack. And we want to have it adjustable. So we're going to go down to the seagrass definition, which is at this point for me down on line 57. And its arc size, the first, remember from arc, the first one is the angle of the arc, meaning like how much of the circle it draws, which we don't want to mess with, but we do want to have it an adjustable size. So we are going to have this receive a parameter called size. Now, you can reuse parameter names because they work like local variables. We'll talk about global and local variables at some point, but everything that happens inside of that function is invisible to the rest of the program unless it gets called. Or even when it's called, it doesn't. You can reuse names inside of different function definitions because they don't talk to each other. So we are still going to have this one called size. Again, we could call it anything. And we want to write it so that whatever number we send gets applied to the radius of the arcs that we make. So instead of going forward exactly 100 each time, we're going to go forward whatever number we send it each time. Well, not move forward, the size of the arc of the seagrass. And now we need to go up to where we call it, draw seagrass, and send it a number. Okay, the default was 100. So maybe let's see what 50 looks like, and let's see what 150 looks like. I'm not even sure. Okay, there we go. It's the same shape, the same function, but we can make different sizes now because we can adjust the size of these arcs. They're still 30 degrees, 60 degrees of the circle that they're making, but completely adjustable. Maybe, I don't know. I don't know why I spend so much time fine tuning. There we go. I don't care if it goes off the screen for this one. Okay, and that is it for bubble 12. And we are definitely going to get through this. Yes. Okay, all right. So draw fish. Draw fish. We want to affect the parameter or affect the let's try that. We want to be able to draw a customizable fish. And so now we're going to adjust the size. Okay, so fish is draw fish is a an interesting function. We can look how it works. For me, it's down on line 73. Okay, so it uses a pen width of 30 to draw the line. It also makes a dot of 30. The dot is the head or the body, I guess. And then the tail is a series of, it's like a triangle. But it uses the same size for the body as the size of the triangle. And we're going to fix that eventually. Let's go like this. And why is that like that? This is period 1, right?
Yeah.
Something weird is happening. Okay. So let's make it adjustable. Let's call it size. And we want to use the word size anywhere we have a move forward. We still want it to be a triangle. We just want it to be adjustable. Okay. And now when we call it, we want to send it a number. Its default, or what it was there was 30, I think. So something in the range of 30 would work. Let's try just half and double. And this will not look right. The reason why it doesn't look right, not only because they're on top of each other, it's still using a, let's move it over. It's still using a hard-coded body size. It doesn't, well, also the big one is too big. Let's try it like that. It's using 30 for the size of the body, no matter what size the tail is. And we're going to use that variable or that parameter as the size of both the pen width. Okay, so let's increase pen width and see what that looks like. I mean, I guess slightly better, maybe. But we also want it to be dot, the size of the dot. That way, wait, and we also need it to be the size of the, hold on, let's see if that works. Yeah, there we go. So this function is designed where the size of the body, which is the dot, the size of the tails of, or the size of the sides of the tail triangle and the thickness of the pen are all related. they all need to be the same in order for this function to end up looking like a fish. And it was fine when everything was exactly 30. It worked great. But if we want to draw a bigger fish, we need all of those aspects to be the same as each other when it's called, which is why we have size for it, the size of the pen, the size of the dot, how far away the triangle starts from the center of the dot, and the sides of the triangle. So just, well, you could count and have be sure that it's used 1, 2, 3, 4, 5, 6 times inside our adjusted draw fish definition, or you could run it and see if your fish looks wonky or they don't look identical scaled. In which case it would need more attention. All right, so we can also adjust color. So far, we've only used it to adjust size, but we can write a function that will allow us to draw the same thing in different sizes and different colors each time that we want to call it. And so we are going to have our function draw fish receive a color. But a color has 3 components, red, green, and blue. So we're going to have it send, and we'll expect to receive 3 more parameters. The first one being the red value, the second one being the green value, and third one being the blue value, which actually are going to be the second, third, and fourth parameter because we already have size. So those are going to be our 4 parameters. You could have it send and then receive a named color, but with what we're going to do shortly, you can't use a named color because you can't randomize the color, the named color, but you can randomize the amount of red, randomize the amount of green, etc. So in order to do this, let's go down to the definition. We want to make sure that we have a place to put things. And so draw fish. In the draw fish definition, which for me is on line 73, we need to add 4 places. The first one is going to be the redness, and you can use the word red. I'm not going to, because I want to make sure you know the difference between words you have to use and words that are just useful for meaningful and descriptive, whatever. Okay. The next one's going to be green, and the next one's going to be blue. Now, they don't have to go in this order either for the sake of receiving the parameters, but there's no reason not to, and it's going to get confusing if you use the wrong value and apply it to the wrong place. So just for everyone's sake, do things RGB forever. And yes, this is the second parameter, but and the third and the fourth, but it's still red, green, blue. And your parameter names can be a single character. They can't be a number. Can they be a capital letter? Yeah, I think they can be. Wait, does it? Yeah, okay. So it can. Yeah. So how are we going to apply this? Well, how does each fish get its color? It gets its color with this first pen RGB call. And so what do we want the red to be? Well, we want the red to be whatever we send it when we call it. What do we want the green of this pen RGB to be? Well, we want it to be whatever we send it with the green parameter. And what do we want the blue of this to be? We want it to be whatever blue. And starting to realize that RGB might be taken as a whatever. Just we'll figure out things you have to call things and things you get to call things as we go. And this is our only color adjustment in this definition. So as long as we send it values in the second, third, and fourth parameter when we call it, and those values are between 0 and 255 inclusive, they will get applied and used correctly to set the color. So now in order for this to work, we need to go up to the function call, draw a fish, and send it 3 more. In this case, this is where we're actually choosing the values for it to use. And at this point, we are going to hard code our different colors. Very shortly, we'll do random colors. But let's make the first one. I mean, it doesn't really matter. Let's see what that color is. That's going to be a heavy blue, medium purple, and kind of brightish. And let's make a, like I said, it doesn't matter. 255, 200, 100. That's going to be a yellowish, I think. Thank you. Yeah. Okay. And now we can make fish of any color with this function, well, with this function definition that's expecting 4 parameters. And I think you'll agree that writing a single function that can make a fish any size and any color is convenient. Instead of writing a new function for every different color that we might want to use, or every different size, we can have it all in one chunk of code that is super convenient. And I think that's all we need for this one. Where okay, so up at your function calls, which are at line 25 and 7, you need to have 4. You need to send it 4 different numbers. The first one is the size of, and then the other 4 are the redness, greenness, and blueness of this particular fish. Was that it? Okay, the function call actually gives the value, and the definition receives it, stores it in whatever you name the parameter, and uses it however many times you want inside of that call. We good? This draw fish needs 4. You need to send it 4 numbers in order for it to do a thing. We can come back in a second. I think we got one more. We'll come back shortly. Ooh, that was a mistake. Okay. So now we get the random number block. This is fantastic. We're going to use this all over the place. Excuse me. You do need to know how it works. Now, in AppLab, when you call random number, you're going to give it 2 parameters. And the 2 parameters it's expecting are the high and low value, the range of the randomness you are expecting. Okay. Let's go up to 15. Yeah. Okay. And for AppLab, it is only going to give you whole numbers, and it's going to give you a random whole number between those minimum and maximum value inclusive. Okay. So random 0, 1 will give you either a 0 or 1. It's a good coin flip situation. And that's different than for real JavaScript, where if you do a random number range, it will give you a decimal between the range that you want, and it, which is fine. It will, you can always do round or floor for the, to solve it into a whole number, and that's super common. The problem with this one is if you do want a decimal, the way you do that is random number 1 to 100, and then divide that answer by 100, and that will give you a decimal, a 2-digit decimal. And we'll work around this, but for the most part, this is a good way to learn how to do this. And we are going to use it to adjust the size of all the things for, what are we supposed to do it? Let's do random number for all three. Let's just, let's say we have to do it for color also. All right, well, we'll just use it for the parameters that we adjusted. Okay, so draw starfish. Let's do that one first. Draw starfish, the function, whatever number we send it will be its size. It's the side of the length. So instead of giving it an actual number, like a hard-coded number, we're going to send it a random number. Okay. For those of you new or struggling with the drag and drop situation on a touchpad or, God forbid, a touchscreen, once again, strongly recommend getting a Bluetooth mouse. They're not very expensive and they are life-changing. Okay, so each time we're going to send it a random number, but we need to give it a valid, a useful range, which before 30 was a pretty low number, 60 didn't really work. Let's try a range between 20 and 50 maybe. And you don't need to use the same range for both calls, but you might as well. They're going to come through as different sizes usually. Wait, draw starfish. Let's make a bigger range so we can actually see some sort of random size. All right, so you can see sort of that our random range is relatively narrow, but you can see they are coming in different sizes each time. And that's the point. That's all we've adjusted for starfish. We don't need to change the definition at all because this is still working the same. We're still going to send it a number that's used for its side length. It's just every time we call, we're going to send it a different number, a number that we don't know because it's random. Okay. For draw seagrass, let's go look at the function definition for draw seagrass. It only receives one parameter that is used as the arc radius. And we started out with 100. Let's see what a good range would be for draw seagrass. Yeah, so 50 was pretty low. Let's see if 40 is an okay version for our, yeah. So we're going to use 40 as the lowest and 120 as the highest. So we're going to send a random number as the parameter for seagrass with a random range, that a range where we're happy with any value in that range. Okay, that's important to note. How to choose a good range. That looks good. I mean, of course, you could do 1 to 400, and you would get a big, well, yeah, so that's significantly bigger, which is not what we're looking for. We are looking for realistic, just random. Okay, and the last one is the draw fish, which, so draw fish sends 4 parameters. It's going to get crowded when you start dragging things in there. In fact, it's very easy to run out of space. There is a scroll over situation where you can then, I don't know, it's sort of awkward to get around. It is, the way I would do this, if I was very limited and didn't know, I would probably zoom out. Control minus is zoom out. That'll give you some more space. You can switch to text mode, except be careful because in text mode, we are dealing with commas and other punctuation and syntax that you can mess up and not be able to get back to block mode. So unfortunately, these blocks are huge. And let's, like I said, I'm gonna zoom out a little bit so I can get them all in there. And so our first one is our range of size, which what was a good range? I think the original was 30. So maybe 15 is the smallest fish we want, and maybe 50 is the largest. And the next ones are going to be our red, green, and blue respectively. And if we want a color on like a completely random color, we have to do 0 to 255. 0 to 255 for the green, and 0 to 255 for the blue. This will give us a random size and random color fish. And if we want 2 of them, it's easier just to copy it and paste it. Okay, so this will give us completely random fish color. All those were pretty close. And we could leave it like that. Well, we'll get to coming up with a more useful range, like having all the fish a random red color, where they're all red, but like different reds, where you would just have a random number for, well, we'll deal with that later. Okay, so there we go. We've got functions, sending and expecting parameters. We've got random number. Got all this good stuff that'll be around for a long time. Let's take a look at, no, that's not it. What is this one? Let's take a look at the checks for understanding. And bubble 17 is something also. Let's take a look at bubble 16. So looking at bubble 16, consider the various uses of random number. Each answer describes the use. Each answer describes the use and shows a code example. Which of the following is not a valid use of random number? Okay, so we have a function call that's sending a random number. Great. We have a function definition receiving a random number. Calling, no. Function definitions do not give the values. They receive and expect the values. Okay, moving forward, turn left and pen width are all great ways to use random number if that's what you want. We'd probably put it in a definition, a function definition, and have it use a parameter. But this is not how you use random number or how you use any value in the definition. Okay, for bubble 17, keep adding to your drawing. Just call, what does it say? Just call one more of each should be enough. Keep adding to drawing. Yeah, call one more of each. That's all you need. And you already have, well, we can do random XY. There's no reason not to, but just for each of them, throw in, oh, this is my other one. Copy the move to with another move to value and repeat your one of each, the fish, the starfish, and the seagrass. All you need to do is copy the pair of move to and the draw with random numbers, and the move to needs another useful value. And let's look at bubble 18. Okay, another AP practice performance task, create task, digital portfolio, written response question, where this one is a hypothetical student's code, and we have a function definition. This written part is, does it have a written response? No, it doesn't have a written response, but in your project, you will hand in a copy of your code and put a square around the area that you're talking about in the written response so that the grader can see what you're talking about instead of having to dig through your code. And this question is about, again, about using abstraction you developed. Okay. This is a student developed abstraction. It's a function definition that was written by a student. It's not just all turtle commands. And so below is a code, some code from under the sea, drawn around a portion of code. Imagine you wrote this and are composing an AP response about how abstraction manages complexity. Ignore the requirements of the abstraction. Integrate mathematical logic. Okay. So the question is, explain how the abstraction marked with the rectangle in the code above helps manage complexity. How does this function manage complexity? How does it decrease the need for extra code? How does it make things easier and more useful and solve problems that you don't have to solve again? Kind of thing. Okay, bubble 19, choose select two true statements. Okay, parameters can only be used once in the body of the function. Absolutely not. They can be used as many times as you want. And they can be used for different things. Just like we saw in the first go round with the fish definition, we use size for the size of the sides of the triangle and the size of the dot and the pen width and the distance the triangle is away. It all used the same parameter. We sent a single number to the function when we called it, and that number was applied several different ways because it all needed to be in scale. So this is not true. Functions with parameters can be used to prevent creation of duplication code. That's the point. So that's absolutely true. The point is this one chunk of code can be used a ton of different ways. You don't need to rewrite it or write slightly different version. Okay, parameters help generalize the solution of a specific problem. Generalize the solution. Yeah, sure. And let's see if one of these is truer or this one's truer. Values do not need to be provided to a function with parameters in any particular order. Yeah, they need to be in order that you write them. So the function definition is expecting whatever you called it, the first thing in your list of parameters, it's going to be applied to the size. So when you call it, that first one, whatever number in that first one you send is going to be applied to that. So the order that you call them, the order in your function call needs to be aware. You need to be aware of the order in the definition. So this is not true. Okay, so functions can be used, prevent duplicated code, and they generalize a solution, which are kind of two ways to say the same thing. Okay, abstraction is often used to focus on a general case and ignore specific problems. Given this meaning of the word, how are functions with parameters an example of abstraction? Okay, you're seeing that word all over the place, and that is not a coincidence. Okay, so that's it for instruction.